Stefan Fischer from the company Kraft Maschinenbau, who is working there as a project manager in the area of services and responsible, let's say, to align the company strategically in this area of smart services, digital services, in as a whole. And he will also talk about very exciting topic, which is called why it is hard to gain customer value with data-driven services. So even though it is always sounds very good and promising that it's really the right thing to do, it is still quite difficult to gain some customer value with the data. So Stefan, are you there?
Yes, of course.
Hi, so I suppose you will share your screen now?
Yes, correct.
And yeah, we are looking forward to your speech.
So as introduced, my name is Stefan Fischer. I'm working at Kraft Maschinenbau as a product manager for digital services. And I want to tell you something about why is it hard to gain customer value with data-driven services. So as we heard before, data-driven services or digital services is the right way into the future, but it's typically not easy to develop these services, and also not easy to gain customer value with these services. So short introduction to Kraft Maschinenbau. Who are we? We are an owner-managed business in the 7th generation, founded 1816 as a blacksmith. So we have over 200 years of experience and expertise in working with steel, I would say. We are one of the international leading customized special machine manufacturers. We build complete individual manufacturing solutions, mostly independent of the industry, with a main focus of the wood processing industry. And to extend our product offer and also to extend our production capabilities and to be able to offer fully production lines, means from raw material up to the packed product. We got this year the majority shareholding in Becker Sondermaschinenbau. It's a company with focus on sewing and packaging technologies. And in the whole group, we are now approximately 600 employees, with an apprenticeship rate of 12%. So that shows that we place also a high value on training of our employees. What we're doing, we're always talking about everything from single source. So we're building automated production lines. And typically we start with a product or production process idea from our customers. So they come to us, they say, okay, I have your product, I want to produce it, or I want the production line for this product, or I have some new production process idea. And then together with the customer, we start the engineering of a customized machine according to the idea and or the requirements of the customer. In our halls or in our walls, maybe also, of Kraft Maschinenbau, we are starting with the project engineering. We're doing the construction of the machine and also the mechanical processing. So means the machining of steel with regard to the production, as well as milling, welding, and also painting of machine parts, everything here in Friedberg Maspolte. We assemble the line, the production line, and we also do the automation. That's one of our most competitive strengths, the automation technologies we have. And for me, it's always something like bring the system to life. So automation means controlling of actuators and sensors at first. And in the second step, it means also to implement the production process so that really you can start with raw material at the beginning, and at the end there is a packed product. So that's something really great, and we are very strong in our automation technologies. So we are building automated production lines, typically for doors and frames, floorings, insulation materials, building elements. packagings, and also for special areas. So means for our customers, customer products or customer requirements. For example, processing already of radiators, and we're not ending with with the assembly and the automation of the production line. We also offer after sales services. So we're offering spare parts, maintenance, retrofits, and also in case of downtime at the customer, we have a service hotline. He can call us and he always gets help. So why do we as a manufacturing company need data-driven services or digital services? I have here 3 levels on the perspective of the manufacturer and also on the perspective of the customer. The first level is the visual level, I would say. So of course we need to expand our product portfolio. We need new additional features. We need to support, or we need features to support our after sales services. And typically these are some digital products or some digital services. Our customers today not only want a good production line, they also want more transparency in this production line. So they want to see how good the lines are performing, what do we have for errors, and they want to analyze it. So in the history, they want to see what this machine do, and also they want additional information. So they want not only to use the machine as a production line, so they want to work really with the machine. And additional information is something like technical documentations or training videos, maintenance videos. So something that helps the customer to operate the system in a good way. I would say in a deeper level, what we want is market differentiation. I think it's clear. So we want to save the customer loyalty as a manufacturer, and we use our application expertise and also the application expertise of our customers to build better products or to improve our machines. And on the customer side, they always want less standstill time. So they want to avoid not planned downtime, want to have a lot of uptime, of course, and faster fault identification and rectification. And I think, or I would say the last level, so what do we really want with, or why do we really need data-driven services? It's in the perspective on the manufacturer to hold the interface to the customer. That means we want to collaborative work with the customer, so improve our products, and also gain knowledge and field data of our product in the lifetime of the product, so to get a better feeling how our customers are working with our machines, of course, to get implications for new products and to get new innovations. And on the customer side, we always want more output, higher output. We want to use the machine at an optimized or in the optimized point to get the highest output that is possible. And for this, we need to find always in the lifetime optimization potentials. We need to monitor the machine state. So of course, also to avoid downtime. And the solution for all of these requirements or challenges are mostly digital or data-driven services. So the question now is how to build these data-driven services. So typically we start with a use case, for example, now the clamp mailing, what is also part of the challenge later on. And here's the first critical part, because for the use case, you need a good maturity of the control system. So that means we have to be able to generate and persist data as well as offer them via interfaces, and to do the data acquisition. And of course, the use case has to offer the data. So we need the data availability. If these points are fulfilled, we can start with the data acquisition. And that is also always something that takes a long time, because we do not need experimental data or some generated data. We need real data from real production systems. And we do the data acquisition in real production lines, but the problem is we have, and that's something also in the second critical path, we have unbalanced data classes. So we have a lot of good data, and that's something for our customers really good. So they do not want any downtime or anomalous states, but for us to build data-driven services or digital services, which focus on detecting anomalous states, we need these anomalous states, and we do not have a lot of data about that or about them. And yeah, for the data review and analysis, so for development of algorithms later on, we need also to understand the domain. So we need a domain expert who is understanding the system and also who is understanding the use case and how the production process is working and how the customers are working with the machines. So that also takes a long time to understand how the system really is working and how the behavior of the system is. And that's also something in common with the knowledge management. So the next step is the development of algorithms. I think most of the people here do know the critical point at development of algorithms and to parameterize them and so on. And with the development or with the developed algorithms, we're going to set up the smart service. And here we have normally the third critical path. So to get the acceptance by the customer for these smart services. So the operator of the system has to work with the smart service, and that's something they normally not do. So that's something new, and they have to get some trust in the system, in the smart service, and that's something that takes also time to trust the system and to see that it's really working and it's good working. And if this point or if they see that it's working and they trust the system, that's the point where we get the customer value. So that shows that it's really hard to gain the customer value, because to get customer value, you need a long time of a running smart service to see that it's working and to get the trust. And in common with the customer value, there's also the willingness to pay. So the willingness to pay on the customer side, you always have you get when customers see that the smart service is working and they see the benefit in the smart service. So that's also something that is not from the beginning of the smart service, and you need to work with the customer together in this point. And also it's something about knowledge management. So the smart service is something you do not set up and let it run. So you need to work with the customer. You need the feedback of the customer if the smart service is working well, if it's performing well. And normally customers do not tell you if it's working good or if it's working bad. If it's working bad, they maybe look at it once or twice and that's it. If they see, okay, it's not working like we have, or the messages are not right, the states are not right, they do not work any longer with the smart service, but they do also not feedback it. And that's something really worth. These three phases here are iterative, so the smart service is always developed or improved, and also we do always data review and analysis. And to be or to set up the smart service and to gain and to place it in the market, you need to scale it. So what means scaling of data-driven services? It means that you have to be able to scale it. And we have two ways of scaling. The first is identical applications. So that's something really hard for Kraft because we do not have serial products, or our products are often, they are just for one customer. So they are not in serial produced. And identical applications or scaling in identical applications is only possible with serial products. But in this case, also the algorithms have to be resistant to influencing factors such as the environment or different usage of the machines. And so you need the possibility to easily adapt smart services to peculiarities of the machine. So, for example, variations. The other way is that's something we are working out at Kraft. Scale to similar applications is something not easy. It's more a knowledge-based transfer. You always have to redevelop or reconfigure our algorithms to new use cases. But what we're doing is try to use as much knowledge as possible to reduce the development time. And that's something really critical, because scaling, it's hard, of course. So now as a conclusion, why is it hard to gain customer value? So on the development side, we have, we need a good use case with also good data to develop a smart service. We need, on the one side, the AI expert who is able to analyze and structuralize the data and also develop algorithms. But you also need a domain expert who is able to explain and understand the technical system and the production process. And we need a lot of data. And in common with a lot of data is the possibility to collect and persist data. And on the market side, we need the ability to scale. And also we need on customer side early adopters who maybe try out a smart service, even if they do not trust the system at the beginning. So early adopters, they want new improvements, and also they will work together with us while developing this smart service. Also, you need on the customer side the need for a solution. So you need customers which have application knowledge, which know the problems of their machines, and which see also the benefit in data-driven services, and they see also the need for solutions to work with big data. And if all of these needs are fulfilled, we are able to try to gain customer value with data-driven services. And all of these, you see at all of these needs, that it's hard to fulfill of these needs, and that it takes always a long time to build up a data-driven or a smart service. And that's why it is hard to gain customer value, because it takes a long time, and it's something where you need a lot of expertise and co-development with the customer. So last but not least, I wish you good luck with the challenge from Kraft Maschinenbau, and also I am now open for questions.
Great, thank you, Stefan, for your very nice presentation. So do we have some questions?
I would have maybe a question, and it is about edge devices. How do you deal with such devices that has limited power, limited possibility to do mathematical, already, I guess, the question.
Yeah, really interesting question. Not easy to answer also. How to answer? Normally, the question is which kind of algorithms do we have on the machines, and which power do we need for these algorithms? Typically, you have fully trained networks, or maybe algorithms which are not on AI based or so easy mathematics. And in this case, you do not need a lot of power, and you can, or you are able to work with edge devices on the machines.
Thank you very much.